So that effective rate problem, we did the savings bond at 1 year. Again, like I said, even though it didn't state ordinary interest or exact interest, we used it because we're assuming that paying out, they're going to do what benefits them. And the 1 year time frame, that's the simplest way to do it. But let's take a look now at a Pat takes a simple discount note on borrows, but takes, same thing, on May 19th for $4,900 at 9.3%. The note is due on August 15th. Find the effective rate. Well, this one adds a layer of difficulty for us. Let's find the dates here first. May 15th is what day? 139, and August 15th? 227. So how many days is that if we subtract? Yeah, 88 days. Perfect. So to find the effective rate now from those days, we first have to find the discount. And our discount, of course, is going to equal what?
Same thing as the interest.
Okay, so how do we find it?
4,900 times 0.093 times 88 over 365. Careful.
We did go, oops, I wrote 365 too, and I shouldn't have. 88 over 360. So since this is, Pat is borrowing, we are assuming ordinary interest here, so he pays the most. They said the exception to that is the treasury bills and savings bonds. Those will get figured out on exact interest, even if they're not stated. So we figure this out, we end up with $111.39. Does that look right?
Yep.
So that's the discount. Proceeds are going to be $4,900 minus the $111.39, which is going to be $4,788.61.
Is it? Oh, never mind. I read it.
You've got it?
Yep.
Okay. So now effective rate, because our time isn't quite so clean here, is going to be a little bit trickier, but not much. What goes first here? Sure. Careful. We have to start with the amount of interest, the discount, the $111.39. Then it is the 4,788.61. And then the rate, and then the 88 over 360 for the time. And now we do have to combine the principal and the time here, or the proceeds in the time in this case. 4,788.61 times 88 divided by 360. 1170.55. Now again, I'm keeping that in my calculator so that I don't have a round off in this next calculation, which is going to be to Divide by 1170.55. You've got the 1170.55. Just leave it on your screen for now. And in just a second, I will show you how we reuse it. So what you're going to do on your calculator to keep that in the calculator is you're just going to type in 111.39. Then you're going to hit divided by. Yep, just type 111.39. Divided by. Then you're going to press the second key up in the top left. And then the negative key down by your equal sign says ANS above it. Hit that. So it's telling your calculator to divide by the previous answer. We get 0.09516 equals my rate. Now I did not tell you how I wanted this rounded, so let's round to 1/100%. So what's this going to come out to be? 9.516, which to 100th is going to round to 9.52. Perfect. Believe it or not, I see several students in the My Math Lab homework and the quiz when we get to it that will do all this calculation correctly but round off incorrectly. So be careful with that. Most of the time in My Math Lab, I'm pretty forgiving if it's a round off error, and I go back and give you back credit for it. For these, if it's a round off error, I won't give you back more than half the credit for it if I catch that error. Just so you know, because if you're working in a bank, they are required to disclose their effective rates, and if it's a federal regulation that's saying they must disclose that effective rate down to the 100th%, that better be on this line to the 100th%. I'm going to have you guys try an example like that. Sam borrows $3,400 at 8.35% on November 27th on a simple discount note to be paid back on February 22nd. Find the effective rate in your notes. By the way, I'm going to make a little side note here. Simple discount note is often abbreviated SDN. So if you ever see that in your readings, that's what they're referring to, a simple discount note. So in your notes, find the effective rate. Let's see if you're heading in the right direction. November 27th, is it 230 or 231? 231. And of course, February 22nd is 53. So we are looking at the days in between there, going from November
27th is 3/31.
3/31, I'm sorry. 3/31. So we have now for November 27th to the end of the year is 365 minus the 331 is 34 days, plus the 53 days from the first of the year till February 22nd is 87 days is the period of this note. So to find the discount, we have what? Tell me what to do. Perfect. Our face amount, 3,400, times our rate of 0.0835 from the 8.35%, times our days of 87 over 360. So just to confirm, we've got $68.61 as our discount. So our proceeds, 3,400 minus 68.61, giving us $3,331.39. How are we doing so far? Anybody got it all right so far?
Yep.
Okay. Next step. Effective rate. Tell me what to do.
Take that 3,331.
Hold on, you're a step ahead of yourself.
Whoops. Okay, on the left though, you got 68.61.
There we go. Then it is equal to
The 3,331.39 or 87 over 360.
perfect. So we have our discounted amount, or discount amount of 68.61. Technically, the discounted amount is the proceeds, the $3,331.39, times the rate is what we're looking for here, and then times our time of 87 over 360. So once again, we will combine our proceeds with our time. So 3,331.39 times 87 divided by 360 is 805.09 dollars times R. And again, we're going to keep that in the calculator so we don't round it off. So now we're going to divide by the 805.09. And again, in our calculator, we're going to type in the 68.61 divided by, then second answer, to use that previous answer, is 0.08522. I kind of mentioned in passing that we were to round this to the nearest 100th percent. So we first moved the decimal point. That's 8.522%. And then we round the nearest 100th, which is going to be 8.52%. Now, this next example, I'm going to warn you, will not appear on a quiz, will not appear on a test. But I want to show you how this works. I realize I probably just turned off the brains of 3/4 of the class, but that's okay. Yeah. Yep. Let's say you need $6,000. And you have to get $6,000, which means you cannot take $5,900. You have to have $6,000 because you need that for something you need to do. But you can only get or secure a 9% simple discount note for, and you need that money for 120 days. So the question is, what should the face value of that simple discount note be? So in other words, how much do you have to borrow on a simple discount note at 9% for 120 days so that you can actually get the $6,000? So our first step is going to be to find the effective rate. But you're wondering to yourself, but they're not actually borrowing $6,000. It doesn't matter. The effective rate does not depend on the face value of the loan. The effective rate on a simple discount note is totally determined by the percent and the term. Doesn't matter whether they're borrowing $1,000 or $10,000 or $15,000. If it's a 9%, 120-day simple discount note, the effective rate will be the same. So we can find the effective rate using whatever face value we want to. Whatever face value we wish. This is also true, by the way, in another week when we get to compound interest. We start talking about effective rate. We can get effective rates for compound interest using whatever face value we wish. That is also completely determined by the rate, the compounding period, and the time. Now, since 6,000 was given in the problem, I'm just going to use the 6,000. So I'm going to find the proceeds. Of course, to find that, I first have to find the discount. So if I find the discount, it's going to be the $6,000. That's 0.09 times 120 over 360. Which is going to give us, what, $180? It's a discount. So our proceeds is going to be the 6,000 minus 180, which will be $5,820. So our effective rate we have our discount of 180 equals our proceeds of 5820 times some mysterious rate times 120 over 360. We combine the 5820 times 120 over 360, which is what? I read that wrong. 1940. Still times R. So we solve by dividing by 1940. So 180 divided by 1940 gives us 0.0. I left off both zeros intentionally. I'm being lazy. I figured that's what you're alerted over. So it's 0.09278. And I didn't tell you what to go to, but we're going to go to the 100th of a percent. So make this 9.278%. So 9.28% is that effective rate. So now what we do is we go back and we look at this. What would this be if this were an interest-bearing note? So we're going to pretend this is an interest-bearing note. Well, they're both interest-bearing notes. I used the wrong term. This is a simple interest note, I should say. If this were a simple interest note, and our good buddy needs this $6,000, they're going to get the $6,000 up front, right? Plus whatever that interest is gives us the maturity value. So what we're going to do is we're going to figure out this interest based on that principal of $6,000, but our rate's going to be the effective rate. And the time, of course, is still 120 over 360. If we figure that out, what's that going to be? $185.60, I believe, in interest. Calculate that out. Somebody double check me. I'm not real sharp tonight. So, is it? Okay. So that means the maturity value, 6,000 plus the 185.60 is $6,185.60. That would be the minimum face value for a simple discount note for you to receive that minimum of $6,000 in proceeds. If you were to go through and discount that, you would find the discount. Let's do it. Let's discount it. Now remember, the discount note was 9%. So 0.09, 120 over 360. It's going to be off by pennies because of round off errors, but 6185.6 times 0.09 times 120 over 360 should give us about 185.60. I put a decimal, I missed a zero there. 185.58 is what it gives us. So there's 2 cents in round off errors in there. So you subtract that, they're going to get a proceeds of like $6,000.02 is what it comes out to be. This is a calculation. If you were in investment, working as a loan officer, you would have to be able to do this. Like I said, it's a step beyond what we're doing in this course. So I will never quiz or test you on it. But I wanted you to see that application, that effective rate is the bridge between the simple discount notes and the simple interest notes. That's how you can convert one to the other. Okay, well, the next process we're going to learn, I think, is one of the most difficult processes in this course, only because it requires several steps. So I'm going to lay out a scenario for you first. And in this scenario, we're going to have Kathy is a distributor let's have Kathy distribute brooms. Tim is a broom retailer. So Kathy sells to Tim, distributes to Tim. Tim buys the brooms from Kathy and sells them to customers. We're reaching back a little bit here into last unit. Let's say on May 4th, Kathy sells $400 worth of brooms to Tim with terms 210 net 30. We're assuming shipping is not a part of this problem here for now. So May has how many days in it?
31.
31. So the net 30 would be done on June 3rd. On June 3rd, Tim cannot pay. This next piece is part of the invoice that we did not discuss in the last unit. We just discussed if everything goes out fine, this is what you get for a credit on it if you get the cash discount for paying early. This is what you would owe at the deadline if you waited till the deadline to pay. There's actually an interesting formula that you would see in a basic accounting or basic finance class that shows you actually what percent yield you get for actually utilizing that cash discount. It's really an interesting, like a 2% cash discount depending on the time frames is like a 30% yield on your money for paying the 20 days early. But anyway, we assumed that the bill was actually getting paid by or on the end of that credit period. But what if the bill does not get paid at the end of the credit period? Like here, Tim cannot pay. June 30th is the end of that credit period. Tim cannot pay. Or refuses to pay, one of the two. Most invoices have a stipulation in the invoice that once it reaches that date, it converts to a 12% simple interest note. Most of these are either 12% or 8%. Or, sorry, 12% or 18%. Can anybody guess why? Because 12% is 1% a month. They are going to continue to send out monthly invoices, and they are going to add that interest. Every time they send out the invoice, they're going to consider that an action on that note, and they're going to add in the interest every month. So it's really easy. It's 1% a month for 12%. 18% is 1.5% a month. And so they use those. And this is very common for an invoice to have an automatic clause in that invoice. Hey, the day you miss the payment, there is, they might have a 5-day grace period or whatever. If your payment is not received within that 5-day grace period, we go back to that date. They don't start at the end of the grace period. They go back to that date that the money was due, and they start that interest. So does that scenario make sense?
Yeah.
So what we're going to be looking
I asked about grace periods.
Okay, yeah. And those grace periods are in there. Some of them are, if you miss the grace period, they'll start after the end of the grace period. But most of them, if you make it within that grace period, okay, everything's fine and dandy. We forgive everything. But if you don't make it within that grace period, they go back to the original due date, and they will charge you interest from there on, penalties from there on. So the grace period isn't really a free period unless you get things done within that period. So what we're going to be looking at from here on out starts after this scenario. So you've given somebody a service and they owe you money. And either it is automatically converted into a note, or more often than not, what happens if you have a responsible customer, rather than just allowing it to automatically convert into one of these, 12 or 18% is a relatively high interest rate right now. In the periods like the early 80s, late 70s, that wasn't that high of an interest rate. There were people that were paying 17 or 18% on home mortgages in the late 70s. That's not exaggerating. Now in the days of 3 or 4% mortgages, that sounds ridiculous, but I can remember in the mid 90s when mortgage rates got down below 9%, it was a big deal. What's that?
Some credit cards back down.
And most credit cards are still like, if you don't have a special rate, they're still like 19.9. 14.9 is one of your lower standard rates. Some of the really, really premium credit cards, 12.9 or 11.9. But very few of them have a regular rate of below 10. If you have like a credit union where you have like, you know, a gold member or whatever, you got 25,000 in a deposit somewhere, you might get a 9.9. That's about the lowest I've ever seen on a credit card. Outside of promotional rates, you know, they might give you, we'll give you a 4% on whatever you transfer over to us for the next 6 months or whatever, hoping you don't pay it off in 6 months and then we can really nail you. Yep. So anyway, a responsible customer will say, hey, I don't want to pay 12%. So what I'm going to do is I'm going to negotiate with you. Rather than just putting this at 12% and letting it sit there for however long it takes me to pay it, I'm going to promise you I'm going to pay this in 120 days, 90 days, or whatever. And you're going to give me a little bit lower rate. So we are going to arrange that $400 on a 8% on an 8% 90-day simple interest note. So Tim will pay back at the end of 90 days. Tim will pay Kathy the $400 plus the 8% interest on it for that time. So let's take a peek. What we're going to find here is the maturity value. Of this note. To do that, we first find the interest. So it's $400 times 0.08 times 90 over 360. Which is, what, $8? So, big spenders here. The maturity value is the $400 plus the $8 in interest, $408. Which really is kind of generous because if they'd left it at $12 or the 12%, it would have been $12 after 90 days. So Tim saves $4 by making that arrangement. That's only a $400 bill. So let's look at another situation. Let's say that Kim extends, and that's usually the term, a $2,800 simple interest note. By the way, a lot of times they don't say simple interest note. They'll just say extends a $2,800 note. It is assumed that that is a simple interest note. It'll say discount note specifically if it's a discount note. So Kim extends a $2,800 note to Pat at 8.3% for 120 days. Find the maturity value. Well, this is kind of a step backwards to what we did last week. I'm going to give you a couple minutes to find the maturity value of it. So the amount of interest is the 2,800 times the 0.083, my rate, times 120 over 360, $77.47. So the maturity value is the 2,800 plus the 77.47, $2,877.47. Any questions so far? I'm getting that look of, okay, you said this is one of the more difficult things in the course. It seems pretty much review so far. Okay, well, here's the kicker. Kim gave Pat, whether it's money that Pat borrowed from Kim or whether it's an invoice like we discussed that at the due date of the invoice Pat couldn't pay, so Kim, converted it into this note for Pat to give him an extra 120 days. No matter what it is, however it came about, Kim has lent this $2,800 to Pat for 120 days. But let's say that 47 days into the note, Kim needs money. Kim's looking at this saying, hey, Pat owes me money. I'm just going to go to Pat and see if he can pay me. So Kim goes to Pat and says, hey, I had this thing come up. I've got to have a little bit of cash right now. Can you pay me all what you owe me or some of what you owe me or whatever? Pat goes, you know what? I'm really sorry, but I don't have it. And I've still got, 73 days to go before I have to pay it back. I can't do it. I don't have it. So what are Kim's options? Kim is going to go to a bank. Go to a bank. Yes, we're in North Dakota now. Go to a bank and borrow on a SDN, simple discount note, against the simple interest note that is owed to her. So Pat has this money that is going to be paid back, Kim is owed to Kim. Kim has this money that Pat owes her and is going to have to pay her back. But she can't touch it until Pat pays her back, and she needs it before then. So she goes to the bank and says, hey, I have this money that is owed to me. What will you give me for it? Now, the textbook kind of describes this as selling that note to the bank, and that's not true. Kim really is borrowing money from the bank. They're taking out a note from the bank based on this money that's owed to Kim by Pat on that simple interest note. What is being transferred is Kim is going to give the bank the rights to collect that note from Pat. So Pat does not have to pay Kim, and Kim then turn around and give it to the bank. The bank can collect it directly from Pat. So right now we have Kim, we have Pat, we have the bank. Kim lent money to Pat, And now the bank lent money to Kim. And again, remember, this original note from Kim to Pat was that simple interest note. The bank is lending the money to Kim on a simple discount note. Yes, I understand what that acronym is. Simple interest note is SIN. We'll live with it. Looking at this diagram, does the bank have any contracts with Pat? No. The bank has this agreement with Kim that the bank can collect the money from Pat. But the bank has no contract with Pat. Pat has no obligation to pay anything to the bank. So guess what happens if Pat doesn't pay? The bank will not attempt to collect from Pat because they really don't have any legal standing there. This is what we call contingent liability. Kim has given the bank the right to collect that note from Pat. But like we said, if Pat refuses, the bank has no legal authority to force it. So the bank will collect from Kim. So Kim owes if Pat doesn't pay.
It essentially passes debt off the bank.
Pretty much. The bank's going to get their money either way. They will collect. They just can't collect from Pat. So they're going to go back to Kim and say, hey, it's time. We need our money. We didn't get it from him. You pay. Kim's going to go after Pat for it because Kim does have the contract with Pat. So Kim will go after him and collect it eventually, hopefully. But this is only one form of contingent liability. There are tons of them out there. Like if you co-sign on a loan for somebody, that becomes a contingent liability. You have no responsibility to that bank as long as the person who has the loan pays their bill. But there's a contingent liability. Your liability is contingent on them paying the bill. If they don't pay the bill, then your liability kicks in and they can come after you for it. Okay, we're about 2 minutes early for our break. Well, let's go ahead and take our break and we'll come back and start doing the math for this mess.
You know, just scenarios you gotta understand.